Hi everyone, this is Vivian. Today I'm going to present the 11th Hour project I currently work with FracTracker Alliance. The 11th Hour project are supported by Schmidt Family Foundation and aim to address issues impacting the health of our planet in energy, food, agriculture, and human rights. We're going to cover the introduction and background, a case study telling the impact, and the objectives and challenges in this project. First, let me introduce FracTracker Alliance. FracTracker Alliance is a nonprofit organization who share maps, images, data, and analysis related to the oil and gas industry. Their goal is to, by sharing this data, to better inform public and help people to make wise decisions regarding world's energy future. And then, in order to better understanding the project, I would like to spend several minutes to talk about a little bit background knowledge and important jargons in the oil and gas industry. Please look at the picture on the left side. In the picture, you can see under the ground level, wells are located in different pools. Within a pool, there are different types of wells. In this plot, the blue one labeled as injection wells, the orange one labeled as production wells. How we get crude oil pumped up is that we injected air or gas into the injection wells and increase the pressure in the pipeline to pump crude oil through the production wells pipeline. On the right side, there are important jargons that we need to know as well. Idle wells means wells are not in use for production, injection, or any other activities, but also have not been permanently sealed. Therefore, idle wells would be identified as bad assets for operator in this industry. Abandoned wells is wells that are no longer in the production phase but have been permanently sealed by the operator. FracTracker discovered that designating a well as idle is a temporary solution for operators, but comes a great economic and environmental cost to California. A simple equation defines the problem is that idle wells plus unplugged wells could cause economic and environmental costs and further threaten public health. What FracTracker's mission here is to investigating the industry operators to make sure they're shutting down and properly abandon those wells. And what our mission here is to facilitate FracTracker by exploring oil industry data sets and modeling data at a more granular level. Let's start with a case study. California Resource Corporation, also known as CRC, is established in 2014, originally a subsidiary company spun off by Occidental Petroleum Corporation. According to the record, they own 245,000 wells. Among them, 3,700 wells are idle wells. Looking into their annual report, their revenue stream incurred a significantly declining trend, and their stock performance are really poor in recent years. So the potential question we want to ask here is whether Occidental spin off healthy wells or orphan wells to CRC. Is CRC's financial status as solid as it appeared on their annual report? The major challenges are in the data cleaning process. For the wells dataset, I have to pull out data from Access database. The dataset are pretty huge and we have to join all three together with the same ID exists in all three datasets. After joining the datasets together, we need to impute missing values. Therefore, I need to separate features into either categorical or numerical, and using the mode for categorical features and min for numerical features. While complete the missing value imputation is not the end. We have another obstacle with API number standardization. API number is the unique identification number for each well. The standardized API number should contain 10 digits. However, the dataset we got API number was 6 digits to 12 digits. The API number are either missing the front or the end part. Therefore, we separate the API number by number of digits and match pattern for each group. For the permit dataset, we need to web scraping all PDF from the website and convert over 1,000 PDF to CSV file. It was really hard for those 1990s PDF because the low resolutions, there might incur lots of information in the process. And the only solution is to check back and manually fill those cells. After convert all PDF to CSV, we need to match column name for each CSV and then vertically stack all of them together to one huge data set. After finishing the data cleaning process, we're now ready to do pattern discovery by aggregating data sets on different levels. Now let's look at what we get for CRC. First, we're doing revenue analysis, given the production and injection data of CRC. Since we don't actually have the real-time price data, therefore we use WTI crude oil index as a proxy. And we sum up all CRC's wells production and injection and plot it along time. The x-axis here denotes the date. The y-axis of the upper plot denotes the revenue amount generated by CRC. And the y-axis of the lower plot denotes the injection amount generated by CRC. The red dashed line is the benchmark for 2014. And the blue line in the upper plot denoted the revenue that reported by CRC. We can clearly see that the revenue trend has a clearly drop after 2014, and there is a gap between the revenue proxy and what they actually report. And when you compare the upper plot and lower plot together, we could see a pattern that they try to pump more and more water or gas into the pipe. Whereas we're guessing here is that operators try to increase the pressure and get more oil pump out from the well. In order to do a further analysis on the stage of CRC's wells life cycle and the overall financial health of the company, we generate a plot that compares per well's production or injection amount with active wells number count each year. The axis on the left denoted the production per well or injection per well. The green axis on the right denoted the active wells number. From this plot, we could see that the per well production are keep declining, while the per well injection are slightly increasing, which give us a signal that the well is not profitable anymore. But CRC trying to increase their total production amount by injecting more water or gas into the pipeline to increase pressure and drilling more new wells. In conclusion, by gauging into data sets, we could see a decline in wells revenue generation ability in California oil and gas industry, and a general trend of increase in injection amount, which could imply that operators try to pump out more oil by injecting more water or gas into the well to increase pressure. And the kept increasing active wells count number also gave credit to it. Another possible explanation is that since the plug-in wells fee are expensive enough, that operators keep orphan wells as idle wells instead of plug those wells. What could be going on in the whole industry is what we saw in CRC. So we need to take immediate action to prevent oil operators to drilling more wells and let the operators to plug those idle wells. The future work could be classified into 3 stages. First, investigate whether California's fossil fuel industry are in a declining stage. Second, prove oil operators are carrying idle wells without plugging them because of the cost. The third stage is to increase transparency of the oil and gas industry's practices. Thanks for listening, and also a special thanks to Cal, who got me through this project and let me know a lot of knowledge about oil and gas industry. Then thanks to 11th Hour for their generous scholarship being offered to us. Finally, thanks to the data science program, who provides a lot of interesting practicum opportunities for the cohort.